Assalamualaikum to Dr. Muhammad Syafri bin Muhammad Nasim. Let me introduce myself and my group member. My name is Nur Arisha Umira binti Sharizal. My number matric is A20A1685. And my group member Nur Syafiqah Zaki A20A1777, Siti Nur Hidayah binti Mat Gani A20A1984, Umi Masyara binti Muhammad Sah A20A2051, and lastly Emily Nasra binti Muhammad Nazir A20A1320. First of all is 1.0 is data description. Instruction for this assignment has given the data set contains the following variables. Quantitative variable is liter per 100, fuel consumption per 100 km, KPL, travel distance in kilometer per liter, cylinder, total engine cylinder for each vehicle, horsepower, total horsepower for each vehicle, and weight for each vehicle per 100 kg. Quantitative in turn is brand of cars. Variable that this group decide to choose is 3 of quantitative, which is liter per 100 kpl cylinder. Why? For qualitative is brand. Next, the different characteristics the data set contains. In quantitative category, for liter per 100 fuel consumption, it shows continuous quantitative variable because fuel consumption it involves the speed of car. For KPL, travel distance is known most often as a continuous variable because travel distance can take on any value in some range of value. Next, for total engine cylinder for each vehicle is a discrete quantity variable because we can see that total engine cylinder for each vehicle is thing that we can count number of value. Most often, this variable indeed represents some kind of count. After that, in qualitative category, we have brand. Brand of car is very clear that it consists of qualitative category because it shows name of a brand for an item such as Toyota, Honda, and others.
I will continue with sampling data. This is our result after record all the categorical data in SPSS, which is liter per 100 is fuel consumption per 100 kilometers. KPL is travel distance in kilometers per liter. Cylinder is total engine cylinder for each vehicle. Horsepower is total horsepower for each vehicle. Weight is weight for each vehicle per 1000 kg. Brand is brand of cars. First, the new value of fuel consumption per 100 km is LP ordinal. Next is KPL, and the new value for KPL is KPL batch. Next, cylinder. The new value of cylinder is CL engine. Horsepower is HP speed. Weight is WG ton. And lastly, brand is BR country.
Thank you, Emily. Now we move to the numerical descriptive measure. So there are 3 types of measure. The first one is measure of central tendency. The second one we have measure of position, and the third one we have measure of variation. So we move to the first one. First, measure of central tendency. We have mean, mode, and median. For liter per 100, we have calculated the mean equal 6.093 For mode equal to 4.55 and 7.14, and for median 10.51. Next, we move to KPL. So for KPL, the mean that calculated is equal to 7.74. For mode equal to 14.00 and 22.00, and for median equal to 17.50. Next, for cylinder, the mean that calculated equal to 6.45, and for the mode equal to 8.00 and median equal to 7.00. Next, we move to measure of position. We have quartile, the first quartile, the second quartile, and also the third quartile, and we have interquartile range. So for the first one is liter per 100. We have calculated the first quartile equal to 4.55, the second quartile equal to 5.76, and the third quartile equal to 7.55. The interquartile range equal to 2.30. Next, we move to KPL. So the first quartile calculated equal to 13.25, the second quartile equal to 17.50, and the third quartile equal to 22.00. The interquartile range equal to 8.75. Next, we move to cylinder. So for cylinder, we have calculated the first quartile equal to 4.25, the second quartile equal to 7.00, and the third quartile equal to 8.00. So the interquartile range equal to 3.75. Last but not least, we move to the third one. So the third one is measure of variation. So there are three types, which is we have a range, we have a variance, and also standard deviation. Next, we move to the liter per 100. So the range is equal to 6.21, the variance equal to 3.136, and the standard deviation equal to 1.771. Next, we move to the KPL. So for KPL, the range is equal to 16.4, the variance equal to 24.238, and the standard deviation equal to 4.934. Next, we move to the cylinder. So for cylinder, we have calculated the range equal to 4, the variance equal to 2.997, and the standard deviation equal to 1.731.
Thank you, Shafika. Next, we continue with numerical descriptive measure. In this part, we have to radar tasks from 3.1 and 4.1 and compare the result between manually calculate and using software. The mean fuel consumption was 4.9961 liter per 100 based on SPSS data, while the 3.1 was 6.093 liter per 100. The average for travel distance is 21.055 km per liter, but data 3.1 shows 17.74 km per liter. And then, using SPSS to calculate the total engine for each car, the overall mean is 5.65, while from data 3.1 is 6.45. Next, the second factor is median. The median for fuel consumption is 5.0526 in SPSS, whereas the median for data 3.1 is 10.51. The median travel distance according to SPSS is 19.800 miles, while It is 17.5 miles according to data 3.1. Next, the cylinders median from SPSS is total 6, whereas data 3.1 is 7. Continue with quartiles. As a measure of position, a quartile is a point in a data collection that divides it into 4 equal groups: lower quartile, median, second quartile, and third quartile, median upper quartile. The total interquartile range in liter per 100 is 1.56, whereas the result calculated others, the range of the liter per 100 for full consumption is 4.58, while the total that calculate manually is 6.21. Therefore, the range of KPL for travel distance is 19.1, while the range from data 3.1 is 16.4. The range of cylinder for total engine is 4, which is same with the total from data 3.1. Next, we can see total of variance and standard deviation for each variable. First variable is liter per 100 for SPSS. Liter per 100, the sample variance is about 1.196, and the sample standard deviation is about 1.09349. Y calculate manually is 3.136, and standard deviation is about 1.771. Next, for KPL, from SPSS, the sample variance is about 20.769. Therefore, the sample standard deviation is about 4.5573. Y calculate manually is about 24.238, and for standard deviation is 4.934. Lastly, cylinder from SPSS, the sample variance is about 2.239. Therefore, the sample standard deviation is about 1.496. While when we calculate manually, the value of sample variance is about 2.997, and sample standard deviation is about 1.731. As we can see, this is the total, the result of the comparison from the data from 3.1. After that, as we can see in the slide, this is the 3 of different chart that we do at Microsoft Excel. For liter per 100, we choose histogram chart, and for KPL is line chart. Lastly, for cylinder is pie chart.
Thank you, Arisha. Now we move to the hypothesis testing. So in short, we have 5 of steps of hypothesis testing. So the first one is state the null hypothesis and alternate hypothesis. So we have measured 2 measurement. We have a t-test and also a nova test. So we move to the first test, which is t-test. So the first step is state the null hypothesis and alternate hypothesis. So H null, there is no association between liter per 100 and KPL. So for H1, there is an association between liter per 100 and KPL. Let's see the result. Next, we move to the step number 2, which is we need to state the level of significance. So the alpha equal to 0.1. Next, we move to the step number 3, which is we need to compute test statistic. So we using SPSS for test our t-test. We have this result. Next, we move to step number 4. So for step number 4 is for decision rule. We need to set the rule to make a decision. So for this, reject H null if T over T is more than T 0.1. Since 0.00 is less than 0.1, so we reject hash null. Last step is we need to making a decision and forming a conclusion. So since that decision have been made, so in conclusion there is an association between liter per 100 and KPL because we reject hash null and we approve that H1 is accepted. Next, we move to the second one, which is ANOVA, analysis of variance. So same goes to the t-test. We have step 2 to make a testing of to test our hypothesis. So the first one, we need to state the hash null and also alternate hypothesis. So there is same like the t-test before. Step number 2, we repeated the step, which is we need to set the level of significance, and also we compute the test statistic using ANOVA. So for SPSS, we use one-way ANOVA. So the result of the test that we compute in the SPSS is like this. So we move to the step number 4 for decision rule. It's a bit different between ANOVA and t-test also. So for ANOVA, we reject hash null if F is more than F alpha V1 and V2. So for our critical region is F 0.1, 3 and 1 and 16 equal to 2.46. So we move to the step number 5, making a decision and forming a conclusion. So since F is more or greater than F 0.1, 3 and 16, so hash null is rejected. In conclusion, there is an association between liter per 100 and KPL.
Thank you, Pika. Next, I will explain about correlation analysis using SPSS. In this section, we use percent correlation to measure the strength between the horsepower of vehicles and fuel consumption. 20 data observation is choosing randomly from 393 observations. Next, this is our scatter diagram. This scatter plot allows us to visually see the relationship between horsepower of vehicle and fuel consumption. As we can see, it shows linear relationship. Now, we go step by step to do analysis for testing the significance of the correlation. Step 1. We need to do hypothesis. Hash of, there is no correlation between horsepower of vehicle and fuel consumption. Hash 1. There is positive correlation between horsepower of vehicles and fuel consumption. Now, step 2. SPSS output. Based on our Pearson correlation value, the result of correlation is 0.676 was positive. We know this value is positive because SPSS did not put a negative sign in front of it. So, positive is the default. Since our example Pearson's correlation is positive, we can conclude that when the number of horsepower for each vehicle is increased, our first variable, the amount of fuel consumption, our second variable, also increase. when the value of percent correlation is 0.676. It is very close to 1. For this reason, we can conclude there is a strong relationship between the number of horsepower for each vehicle and fuel consumption. The significant total value in our example is 0.001. This value is less than 0.05. Because of this, we can conclude that there is a statistically significant between the number of horsepower for each vehicle and the amount of fuel consumption. Now we move to step 3, level of significance and decision. For SPSS, we use significant value and compare with alpha value. HO, there is no association between horsepower of vehicle and fuel consumption. H1, there is association between horsepower of vehicle and fuel consumption. For significant value is equal to 0.001, alpha equal to 0.01. So in this case, we can reject HO since the p-value or significant value is 0.001 is less than alpha 0.01. For the last step is step 4, conclusion. We can conclude that there is association between horsepower of vehicle and fuel consumption.
Next, I will continue with confidence interval. We will find the related confidence intervals for the variable of interest using several significant levels. We use 150 observations of 3 variables using several significant levels, which is 80%, 90%, and 95%. This is our formula of significant interval. For our first variable is liter per 100. We use 4.9883 for our mean and 1.79891 for standard deviations. For 95% of confidence interval, the result is 4.6981 and 5.2785. Then, for 90% of confidence interval, the result is 4.7452 and 5.2314. Lastly, for 80% of confidence interval, the result is 4.7993 and 5.1773. The next variable is KPL. We use 22.773 for our mean and 8.1255 for standard deviation. For 95% of confidence interval, the result is 21.462 and 24.084. For 19% of confidence interval, the result is 21.675 and 23.871. And for 80%, the result is 21.919 and 23.627. Lastly, for cylinder, we use 5.57 for our mean and 1.762 for standard deviation. The result for 95% of confidence interval is 5.28 and 5.85. For 19% of confidence interval is 5.33 and 5.80. Lastly, for 80% confidence interval, the result is 5.38 and 5.75.
Thank you, Emily. So next we move to prediction modeling. In this part, we need to interpret the model. First of all, we use three variables, which is one dependent is cylinders, then the other independent is horsepower and weight. For the model summary, the R-square value is 0.815, which means 81.5% of the variation in price can be explained by weight and horsepower. Based on ANOVA table, F calculated is 37.503. Since the p-value from the ANOVA table is less than 0.05, which means that at least one of the two variable weight and horsepower with intersect can be used to model cylinder. For coefficient table, the equation is y equal negative 0.307 plus 1.396 x1 plus 1.413 x2. Here, y can be the number of total engine cylinders, x1 can be the number of total horsepower, and x2 can be the number of weight and for each vehicle. For every unit increase in horsepower, cylinder will increase by 1.396, provided the vehicle weight remains unchanged. Similarly, for every unit increase in weight, cylinders will increase by 1.413 units, provided the vehicle is still of the same horsepower. Since VIF for all predictors are less than 10, there is no evident multicollinearity. Based on this off-normality table, the histogram of residuals shows that residuals have a nearly bell-shaped in bracket normal distribution. This is supported by the p-value of Shapiro-Wilk test, where the p-value 0.001 is lower than 0.05. Note that the hypotheses of Shapiro-Wilk are as follows: H0 residuals are normally distributed, HA residuals are not normally distributed. Ironically, we can improve our SPSS skill as a result of this task. Next, we can describe the general information of the data given. We can record the different variables using SPSS. In numerical descriptive measure, we need to include the formulas to measure the center of tendency, position, and variation. We can practice to draw the illustration of the data set graphically. In addition, we use SPSS and Microsoft Excel for statistical analysis. This can help us to numerical descriptive, measure, hypothesis testing, correlation analysis, confidence interval, and prediction modeling. Based on this assignment, there have several advantages using SPSS, which is when we compare to manual calculation. SPSS greatly aids us in efficiently calculating data. That's all from me. Thank you.